All righty then. We'll start this up again. Weird things going on. Apologize for the interruptions, and we'll try to get through them. Earthquake, a big earthquake in Columbia. And I'm going to repeat this again as I did in the first one. This is not on the same fault as the Venezuela quakes. However, if you're looking at lineament wise, it very well could be. The earthquakes happened up here, diagonally speaking, right there. What? Whoa, waggy. But anyway, let's go ahead and check out this earthquake here. Calmness has made it. Finally, somebody did. Today's earthquake in Western Columbia occurred as a result of primarily strike slip faulting at a depth of approximately 110 kilometers. Focal mechanism solutions for the event indicate rupture occurred on either a steeply dipping oblique reverse or a left lateral strike slip fault, or a moderately dipping, largely lateral, right lateral strike slip fault. This earthquake occurred in the region characterized by eastward subduction of the Nazca Plate beneath the South American Plate. Due to its depth, the earthquake has likely occurred within the subducting Nazca Plate. What does that mean? Happy? Well, let's check it out. Zoom over here, zoom on down, and then come over here. This is the Nazca Plate right here. This is the Cocos Plate. This is the Nazca Plate. Nazca Plate breaks up, and here's the Panamanian Plate up in here, right here, dead center of your freaking screen, right? See this subduction zone out here? That's right. This is subducting underneath this. This is a major fault system right here. This one is connected to the two that were up there in Venezuela. This earthquake is not along that edge. I repeat, is not along that edge. It is on the thrust folds of the subducting plate. All right? Yeah. Now, I already looked up, my attitudes are really bad. I apologize. This earthquake fault right here has ruptured. They said this could be the fault system, the northeast to southwest. That's the lineament. This here is where more breakage happened. It could be that there are two faults happening right now as we speak. USGS has a secondary earthquake going northwest of the main quake. Again, you can see the mountain range right here. The thrust, here's the subducting underneath this plate and the uplift here. This is the same thrust faults that exist up in here, right laterals, thrustful. Sorry. Get it out. Just get it out. Medellin and Bogota in the middle right here. Nevada del Ruiz volcano is right there, baby. And then we have the other one that's been active, which is right about down here. What do we say? Putanyang, or what do we call it? How did we say it? Somebody told me the other day. Purese volcano we've been talking about for, I don't know, maybe 6 months, maybe a little bit less. Purese is right down here. And yep, somebody says puree. Say it with me. Puree. I need a hug. Right? Anyway. What's that guy doing? I don't know. But anyway, so there's a fault. I got to get more coffee in me. No more coffee. 42's there. All right. Good to see you, 42. You missed all the other hoopla. Jeez, man, it's been a tough morning. We did a whole hour's worth of trying to figure out what the hell just happened. the internet went, it shut my sound off. Medellin and Cali, Colombia, right? So there are several faults in here. All these faults that are, except for this one, it goes right down this lane here, right? There are several faults. Let me have pictures of them for you. Here's one, right? It's not real clear. Let me see. Save image. See if I can open that up image for you. Right? You can see the SSM right here. That's the main fault system. All these other faults are due to the subducting plate in the Columbian Trench. Okay? So all this stuff was accreted. Right? That's why I'm saying the fault that's out here, that's the edge of the plate boundary, the South American plate boundary. This one on all here is due to the subduction and the accretionary stuff. The accretionary wedge is out here. All this stuff was accreted. All of this was part of the Pacific Ocean or the Nazca plate. Okay? So I know you haven't been privy to the videos that Canuck and I've made, but this is going to become part of it as he's talking now. The Romero fault system has many faults. New stuff says it can go 1,600 kilometers from Panama to Peru. Ancient terrain boundary. Yeah, it existed out to sea. Correct. The other fault here that was accreted, it was accreted. So there you have it. All right. And you can see the plate boundaries right here. And excuse me. There was an earthquake in 1992, Murindo earthquake, Northwest Colombia. And that was in 92. So these are stuff that, again, when Canuck and I, or when I post them, I think Canuck and I are going to make another rabbit hole, and we're going to bring this information to you the best we can and inform you. Here's another image that I can share with you that will help you see the fault systems down here. Hold on here. Got one, two. Where's that other one? It's really clear. Don't think it's this one. Oh, it's this one right here. Okay. Again, the number, the San Journal fault, number 11. It's number 11 right here. This is the edge of the plate. Okay. All these other plate, all this other stuff out here is accretionary. This is the, also number 11 is considered to be part of the Caribbean plate boundary. All right. Into Ecuador, as you move into Ecuador, that's where the volcanic arc is. We do have a volcanic arc here in Colombia, and it's not super significant like that of the let me zoom in over here for you and open up volcanoes. Dismiss. There's only a few volcanoes that I've found that are active. I mean, there's a volcano there. Come here. It's the highest volcano in Colombia. I better put that one in there, man. It's like, hey, dummy. I just spotted it from space. So volcanic arc is virtually right here. Our fault, our earthquake, I'll show you where the earthquake hit. Way out here. Okay. So this is 7.4. Happened on 8/10/26. And it's an earthquake. So again, it's not on the volcanic arc system, but the volcanic arc system is due to the subducting that's out here. All right. The other earthquake I mentioned in the 19 what was it? Was it 90? Oh, no. There's another earthquake that Canuck brought up, and it was in 95, which is down here. It's on that same kind of system here. This earthquake was a 6.4, happened on 2/8/95. Normally, larger earthquakes don't happen out here. Why? I don't know, but the depth is important to remember. There's also a 97 earthquake. And do I still have that on our list? Let me see. Was it onto this one? Yeah, let me see here. VPub. Let me go back. Neotectonic people are they have stuff out too, so it's really the San Geronimo fault. That's that everything west of the San Geronimo fault. So that is the extent of the South American plate. Trying to get you a clear picture of it right here. And let me open that up. It's San Geronimo, basically right here. Faults are the solid ones. So the syncline is blue. The anticline is green. That's the rising up. Middle Eocene is the purple. All right. Lineaments is the line here. See, there's the lineaments. You'll see what I was saying. San Geronimo fault goes right through the RFS. All right. If I'm correct. Maybe I got to view the publication here. I don't want to lead you astray, so I want to look up this article here. Yeah, the article I've got, which we'll be talking about it with Canuck, linking late Cretaceous to Eocene tectonostratigraphy of the San Jacinto fold belt of the Northwest Columbia with the Caribbean Plateau collision and flat subduction. The collision with the subduction of the Oceanic Plateau is rare and transient process that usually leaves an indirect imprint only through tectonostratigraphy stratigraphic analysis of pre-Oligocene sequences of the San Jacinto fault belt of northern Colombia, we show that the late Cretaceous to Eocene tectonic evolution of the northwestern South American upon the collision of the ongoing subduction with the Caribbean plate, we linked the deposition of the four-arc basin sequence to the specific collision subduction stages and related their bounding unconformities to major tectonic episodes. The Upper Cretaceous Canzona sequence was deposited in a marine four-arc setting in which the Caribbean plate was being subducted beneath the northwestern South American, producing a contemporaneous magmatism in the present-day lower Magdalena Valley Basin. Coeval strikes up faulting of the Romero wrench fault system, accommodated right lateral displacement due to the oblique convergence. That means it didn't hit dead on, it hit kind of like at an angle. In later Cretaceous times, the Caribbean plateau collided with the South American, marking the change to more terrestrially influenced marine environments, characteristically of the upper Pliocene to the lower Eocene, San Cayetano fault sequence. Now, we've talked about that San Cayetano sequence. We've talked about that fault system. Also deposited in a four-arc setting with an active volcanic arc, a lower middle Eocene angular unconformity at the top of the San Cayetano sequence, the termination activity of the Romero fault system, and the cessation of the arc magmatism are interpreted to indicate the onset of a low-angle subduction of the thick and buoyant Caribbean plateau beneath South America, which occurred between 56 and 43 MA. Flat subduction of the plateau has continued to the present and would be the main cause of amagmatic post-Eocene deposition. All that to say is the Caribbean plate and the SSJFB right there at RFS subducting underneath North America or the South American plate. And because of that, the four-arc and all that stuff happening, and it was out to sea at one time, and now it's not out to sea. And it's interesting how the Panamanian plate came into play here and the way it's being contorted because of the oblique fault system that's working there. And you know already that up here where the 7.5 and the 7.2 hit just a little over a month ago, that it rocked, Venezuela really tough, right along the shore and even across the edge. That's the edge of the Caribbean plate. Now, in one sense, it's the Caribbean plate that's moving, causing this earthquake. But it's not one creating the other. It's the entire plate. So, that being said, did this Venezuela quake create this quake? Not really. In totality, it's the Caribbean plate subducting underneath the South American plate that created this. Can the stress be transferred over that far? That's a long damn way to think about, right? I think I've got this one. Yeah, I do. You're talking about right up here, right? And if I measured it, I'd have to jump off of this fault system and mountain range to get there. And we're already, what the hell up in here? We're back to freaking kilometers. God bless it. I hate the Europeans. Sorry if you're European. There's a reason you're peons. As the crows flies, all right? About 700 miles, 650 miles, right? But there's folding and taking place. The fault system that works down this way the ones that work around this way, right? The Caribbean plate kind of comes down and right down this. But this break off down here, unrelated. It didn't create this fault. The subducting plate did. So indirectly, maybe, but you can't say this fault created this earthquakes or this doublet created this one. Can't say it. It's a subducting plate. It's really deep. It's not any upper mantle or upper crust. It's down below the flat slab that's down there. Okay? As I spoke earlier on about another article I read to you. So just keeping you abreast. The I think, did I read that? Did I read this one? No, I don't think it's helpful, but I've got some articles here that I'm working with. So, Pimento Presto. Okay. Yeah, the one in California, that's going to happen. Pimento. It's going to happen. Nothing we can do it. We can't technically forecast that. But what had taken place little more than an hour ago, what's the 7.4 here? Happened on 12:34 UT, and we're already at 15 UT. So yeah, about 4 hours ago, a 7.4 took place in Columbia. Now, let me draw it out here for you. You have a kind of a flat slab like this, eh? And you have the landmass up here, and then the mountains, right? Then you have the kind of the oceans right here, right? What happens is, I think I want to do crayon. Yeah. What happens is part of the more liquidy, because it's all oceanic plate, right? Kind of goes down with this, all right? And as a result of that, that liquidy kind of plate boundary, let's go like this, brown. This is what's kind of subducting down beneath. Subducting is a word for being one plate overriding the other, okay? And this is a little bit older stuff, right? And it kind of gets pushed down here. And then parts of this stuff get all gobbledygooked up in here. All right. It's called an accretionary wedge right out here. Part of it gets subducted, part of it don't. Part of this stuff just kind of continues. All right. So our earthquake and where our earthquake took place is you draw it in red here. Somewhere down here. If the earthquake if the earthquake took place up here or up here, more shallow depth, there'd be massive damage. But because of our earthquake at such depth, there's not a lot of damage. Okay, there could be some, and it's felt further. Okay, because of this plate, it being below the waves of energy going away from it travel further And so the S waves go way out further versus if it happened shallow depth, right? Although they would still feel it, it doesn't travel as far. Okay. Also, this would create more damage, especially in this generalized area, and depends on, how far the quake broke, that damage would be continuous. Okay. Our earthquake being down here, broke, and it stayed deep. And because it did, the surface immediately, in this generalized area would feel it substantially, but they did feel it further out that way and further out that way. So the S waves traveled a whole lot more. In addition, because of the buffeting of the overlying plate, where this earthquake happened below it, it muffled it. Okay. Although it travels as the earthquake travels, the waves go around it. Some of these waves were buffeted down here. So instead of it being, perfectly round out, it was muffled, right? Down underneath. Although they did feel the power go straight up and a little bit off to the sides, it was muffled, and the energy was pushed out sideways, and hence further away they felt it. That's how all that works. And what else? What else can I bring to your attention here? This is a flat slab subduction. What happens on a flat slab subduction? If I drew a line down, which I will draw a line here, the temperature is plus 70 up here, right? Temperature down here at 5 km is probably maybe 500. Then you got to come down to 30 km or 50 km, and it'll go to like 600. And then as you further get down to 70 km, it'll be maybe 800. Okay. The reason there's not many volcanic arcs on a flat slab is because of this oceanic stuff right here that gets subducted because of the ocean, right? This the dirt from the dense oceanic plate, it's filled with liquid. It keeps it cool, but there's no buildup of magma turning to gas and to create a volcano because of this flat slab. So when we look at, although we do have some, these are I think are unrelated. This flat slab that's through here is like the Peruvian flat slab right here. The reason there's no volcanoes in here is a flat slab. The article I read said this area here has a flat slab as well. Because it's oblique, this is traveling like this, and I'll show you. This is traveling at that angle. This is kind of traveling at that angle. They're opposing angles, and right out here is a flat slab underneath this section of like Panama and stuff. So there is a volcanic arc, and that's due to this subduction. This area where the quake happened up in here is not, it's too shallow. You have volcanic arc out here. It's due to some other reasoning than these quakes here. It's just too shallow to create the earthquake. Back to here. So where this earthquake took place, the slab does dive down, but where this earthquake hit is too shallow for all the volcanoes to take place. The volcanoes would be out here. All right. Generally, 250 miles, or about that, 250, and we can do a measure. There's 197. There's the 270 volcanic arc out here. Although there is some volcanoes in here, so these are probably older ones. I don't know how old Nevada del Ruiz there is. One of the more active volcanoes. The tallest one we just found out was right here. Here's Pu Rece, all right, which is active right now. Nevada del Ruiz. There's the triangle if you want to see it. Triangle. But this is too shallow out here to have volcanoes on top. Let me see what this one says. Sierra Taro, Chaco, right there. There's a mountain here. And this would be like along California, the not the Sierra Nevadas, but the coastal ranges. And see, the Pinnacles and Clear Lake aren't due to subduction. They're due to thinning of the plate and the like. The lava plug, all these things were down here at one time and they migrated north. But here's the volcanic arc. It's in the back. This is an ancient one. This is the more current one. And but these mountains down here, there's no volcanoes because number one, down here is a flat slab that took place. It disappeared. All the volcanic stuff is out in the desert, unlike in the Pacific Northwest where it's not a flat slab. It dives down and it gets flatter as it moves up this way. So it's the angle of the I'm going to go there. It's the angle of this arc. So our earthquake today is here. It's not in risk of making at an area where they'd make a volcano because the volcanoes are back here. It's more of a flat area, whereas this is probably the angle of the arc. And how volcanoes work is interesting because the steam or the water, the lithosphere that gets put down in here, boils. The water turns to gas. The gas needs to go somewhere because it needs to go up, needs to rise up. It gets so hot it melts the rock. You're talking at a much higher, and that's how they can tell where the slab is and where it's not. It's due to wherever the rocks begin to melt and turn into magma. See, most people think the magma's down here and there's a crack that wakes up and goes up through. That's a hot spot. More volcanoes, or generally volcanoes, are created by the water turning into another a gas, that gas expanding, cracking the rock, melting the rock, turning it into magma, and depending on how much water and how much stuff can create a caldera, and from that caldera rise up. And caldera is the wrong word, but an area of melt that has taken place. And as it continues to rise up with the gas, it cracks a rock, melts the rock, overlying rock, or melts it, creates these avenues, and then bang, we got a volcano. This is where our earthquake today, it's not in that kind of area. It's in the subducting plate. It's not in the overriding plate. If it was in the overriding plate, more people up here would feel it, and less people further out would. Because this is down below, the vibrations took place and transfer it out further. And it's in a non-volcanic arc area. And that is the reason why we can see where our earthquake is today. And you'll see the four arc basin and then the magma, right? You can see the valley in between here. So that's what's going on, and that's the area and the reason why this quake is not related directly to these quakes. Now, we would say, hey, they are somewhat directed because of the Caribbean plate, that both of them are on the adjacent Caribbean plates. This part of the plate subducting underneath all this. So if I drew a line, right? Everything to the right of that line is South America. Everything to the left of that line is either the Caribbean plate, the Nazca plate, or Panamanian plate subducting underneath the massive South American plate, moving at a northwest direction, and all of this stuff being pummeled and pushed and kicked and the like. You can see the Caribbean plates being pushed by 32 speed of the South American plate, and it's twisting and turning all this gobbledygook up here. Even the Cocos plates being shoved under North American plate, which Mexico's part of North America. Everything being migrated west, northwest as the Pacific Ocean moves northwest. The Nazca plate is like stuck between the Pacific and this. The East Pacific rise here, which we've had several earthquakes on over the weekend, that all that pressure moving north, I would be more inclined to think due to the earthquakes that we had here on the East Pacific rise and the Mid-Atlantic ridge that just popped today at another 5. Let me show you that. The Mid-Atlantic, which 12 minutes before this took place, and then these happened. Okay, so here's an interesting quake, strange anomaly, way out in the middle of nowhere, right? That took place yesterday. We also had a couple of quakes down here. I think I'd have to go 7 days. Yeah, here we are. There's a quake here, a 5.2. Here's a quake, 5.1. Here's a quake, 4.8. And then we had this one at 5.1, right? Couple down here, 5.6 and 4.6. This is the Nazca plate. It's been rock and rolling on its western side. Lima, Peru had a 5.3, 4.6, and today a 4.6. Nothing happening down here really. Argentina 4.5 and 4.6, but these quakes happened here is due to the Nazca plate moving quite dramatically all the way around it, and probably, and it subducts underneath South America as South America is moving at a greater clip. These are moving 40. This is moving 32, 34. So moving 51. So Nazca plate's moving a lot faster than this, but it's diving underneath, probably because there is a lot of the Nazca plate underneath the Andes. And as I drew that map, it's probably like this. And then we have I got to use a crayon. The water that came down created all the Andes, which is quite dramatic. You have the ground mass, all of a sudden, bam, you got the Andes, right? Andes, Rockies, and then it kind of goes out to the other side. And these are all, volcanoes, all the Andes, right? Due to the subducting of this. So that's the South American side. whereas this one's more shallow up in here. And so I hope that helps you understand a little bit the dynamics, what's going around the area. Out of nowhere, major platinum and gold mining there, blah, blah, blah. I don't know what she's saying there. Here's the new wiki on the quake. Yeah, Canucks keeps putting stuff out there. So I hope that helps you understand what's going on here about this particular quake. Now, again, to recap, two faults that crisscross here, right? And their USGS is not sure on what it happened on. This is the Nazca plate. This is the other fault that works through there, quite possibly, because we do have a secondary earthquake out here, which would be on that. But as it responds, but more than likely it's the other, and the orientation you can see like this. And we've looked at faults that are through here, and faults that are going rocking through here. And so we see this is 11. This earthquake happened right in here. I think on 13. That would be the oh, it's gone. I don't have it on this map. Well, that sucks. 11 and 12 are both gone. And I saved that one, so let me see here. Yeah, not even on the image there. So this is 11, or 11 turns into 12. 13 is up here, right? It's on the combination of that. The 11 kind of goes out this way, or out this way right here. So it's on the accretionary stuff. This is all accreted. This used to be out to sea. It's been since brought in, much like the Pacific Northwest has as well. I think that's good enough up a report for you on that. If you have any questions, or if you have a different idea, or if you find an error in that rendition I just gave you, go ahead and send me a message. You can find me over on twitch.tv/JoeSlickLive, or you can send me a message on JSL discussion@gmail.com. Appreciate y'all. Remember, don't get none on you.